Hi. Hello. Good time of day. Um, it can it could also be night. Anyway, hi. I was so stressed, yesterday, trying to fix, the stream, and I think things turned out way better than I expected, especially, like I was just like digging myself deeper into a hole, and then when I got my head out, I realized there are better ways. And I, I think now the tracking is instantaneous. It's much better than what I was using before, and way better than yesterday. Even if the method is not my favorite, it works. I'm happy with it. Um, yeah, yes. And the chance of cutting off should be really low because I am connected by wire, which I trust. Um, yeah, so I'm happy. Yeah. Thank you. I should move the mouse. I also think that it's better quality overall. And the just stop moving so much. I just like it. Um, the you know, the transferring is the connection thing. It feels instantaneous. So yeah. Um, nice. Uh, quality looks better as well. I agree. We did it. I'm happy. Um, yesterday's hard work was not for naught. Yeah. So this is a normal stream. Let me double check in case the title is changed. I don't think it is. Let's go to the channel. Yep. Yeah. Title is normal. Cool. And let's, where was I just now? There we go. Okay. There. I should remember what I was doing, right? I should probably run. So, okay. HuggingFace, NLP course, main task, summarization. And so we are just starting with the metrics. We did metrics. Something about rouge, not rogue, right? Rouge. Um, Okay, I think I remember some stuff. So I should definitely just run it so that when we get here, it is reasonable. Yogi Kazi, right up. Oh, I remember. I need to upload. I have it. I didn't delete it. Yeah. Okay. Let's go back here. Upload the stuff that needs uploading. Stuff. Too many stuff. One stuff, two stuff, three stuff. They're all zips, which is fine because we can. Oh, last time I said maybe it causes internet to be slow when I'm uploading, but I don't think so. Upload rate is fine. Okay, test and train is the only one left. Let's go back to this screen. Oh, well. What's happening? Why is the background not changing? Oh, no good. Uh-oh. Does it change when I go up and down? No, it's... Huh. Background is stuck. Well, let's fix it while we are at it. Display capture. And go. Huh. Cool. All right. Oh yeah. See, it's loading. It's not all done, but it's loading and internet is fine. It's just a luck thing, I think. Yeah. So while that's happening, I don't think I'll get a notification, but I should. Why am I holding the mic? I'm holding the mic. And that's causing me to have less hands. Okay. Nope, that's too far. Anyway, interesting, very interesting. So yeah, just a quick summarization is that this is that was funny. Quick summarization is that this is a summarization task, and just reminding myself what I'm doing. We're using T5. It is summarizing in multiple languages. I think they chose French and English, and we chose Spanish and English. And we are using Amazon reviews and oh, Bart is not multilingual. Got it, but Bart is. And we processed the data, but I don't think we did anything special. Yeah. Tokenize. And then for metric, we used Rouge score. Recall. Oh, I remember. Recall oriented understudy, or I don't know how to pronounce this evaluation. What do I remember? Recall, precision, accuracy, F1. Got it. My favorite stuff. Inside joke with me. Okay. And then, yeah, we used NLTK, which is for tokenization, I'm guessing. And then there, we are right here, fine tuning. So let's start. Yeah, all right, this is already as well. So let's say run before, so that when we come here, things are ready. Fine tuning a model for summarization is very similar to other tasks we've covered in this chapter. First thing we need to do is load the pre-trained model from we're using a small checkpoint. Okay. Tried to hold off the cough, didn't work. Okay. So first thing we need to do is load the pre-trained model from the MT5 small checkpoint, since summarization is a sequence-to-sequence task. Okay. We can load the model with the auto model for sequence-to-sequence LM class, which will automatically download and cache the weights. Okay. We're still running. Cool. Ooh. Nice. I think the Rouge score takes a bit of time, but if it goes to like hours, I'm just gonna stop it. Okay. If you're wondering why you don't see any warnings about if you're wondering why you don't see any warnings about fine-tuning the model on a downstream task, that's because for sequence-to-sequence tasks, we keep all the weights of the network. Compare this to our text classification model in chapter 3, where the head of the pre-trained model was replaced with a randomly initialized network. Okay, so we're keeping everything versus random. Cool, good to know. Okay. Next thing we need to do is, by the way, I got a Google News thing that says HuggingFace 5. Is it? I didn't know what it was about. It was just a headline. I didn't click. So yeah. Next thing we need to do is log into the HuggingFace hub. Oh, we did it! Yay! That didn't take long. So this is me logging into the hub. Our score is not good. Okay. Login successful. And then, which will display a widget. And now we're good. I know how to log in. I think like how long ago me? 8 months ago me is really proud of me right now for knowing how to log in into HuggingFace. We'll need to generate, or maybe 12 months ago me, I'm not sure. Summaries in order to compute Rouge score during training. So, yeah, fortunately, the HuggingFace Transformers library provides dedicated training sequence training argument and a trainer class that can do this for us automatically. I don't know why this thing is in my mind, but I will say it. I think last time when I was pronouncing something and you told me that it sounds British, I think I tried to over enunciate during stream. Like if I was talking to a person, I'd probably, my words would be like more, I don't know, like together, but when I read something, I'm trying to enunciate as good as as good as I can, as well as I can, so that people can hear me even if they're not looking at the text. Because I can just like say automatically, but I feel like, I don't know, I feel like it gets lost. Maybe not. Maybe I'm overthinking. Who would have thought that I overthink? There was this YouTube video that was recommended to me, Yoga with Adrian, but for overthinkers, I was like, okay, that's on my to-do list now. Okay. To see how this works, let's first define the hyperparameters and other arguments for our experiments. Defining hyperparameters and other arguments for our experiments. Okay, so we have a batch size, that's 8. Number 8 epochs? That's a lot. How many steps is that? Steps is being computed. And then we have our model name. And then this is the information. Ooh, I should probably, oh, wait. You're Espanol? Wait, was Spanish all along? Hold up. Why did I think it wasn't Spanish? Really? I thought we changed the language. Am I wrong? I mean, yeah, I'm calling Spanish, but I thought they were calling French. Huh. Interesting. So it was Spanish all along? Cool. Sure, I would be proud. Cool. I'm actually curious about our steps. Milk queso, how many is it? 700 steps. Surprisingly less than I thought. Cool. And then the compute metrics. So we have a predict with generate. Where's that? Here. That is set to true. It's an argument. And it's set to indicate that we should generate summaries during evaluation so that we can compute Rouge scores for each epoch. Okay. Cool. So Wow. So prediction happens while for each epoch. That's cool. I think it was maybe the French accents of some of made you remember French? Huh? What? French accents? Really? Presenters? I don't know. But like the video people? Maybe. Oh yeah, that I remember. That I remember as well. Uh-huh. Yeah, I don't know French. I just yeah. I actually recently watched oh no, the cat is calling for me. I'm gonna ignore it. I watched something French recently that I really loved. It's called Dunia something. Dunia. How's it written? Dunia, Dunia. It's an animated movie. Animated movie. Why can't I find it? Help! It's French. It's about refugees. French. Help me find it. Nope. Dunia and the Princess of Aleppo. Yep. It's beautiful. And it was French, and I really liked it. And this is the French title. I suggest. I remember the part where I was like saying these are the French words that I know. Yeah, here. So it was a beautiful movie. That if you watch alone, probably feel like crying, even though it's not the saddest thing. Like it could be sadder, and I'm happy that it's not so sad. That's just a privileged thing to say. I'm happy that the movie didn't make me sad because I didn't live through it. Anyway. Okay. So yes, for each epoch, got it. So the decoder performs inference by predicting tokens one by one, and it is implemented by the model's generate method. Cool. Setting the predict with generate to true tells the sequence to sequence trainer to use that method for evaluation. Cool. We've also adjusted some of the default hyperparameters like the learning rate. Did we? Okay. Number of epochs and weight decay. Yes. I see it. And then we've set the save total limit option to only save up to 3 checkpoints during training. That's actually really useful. It's because even the small version of T5 uses around a gigabyte of hard drive space, and we can save a lot of room by limiting the number of copies we save. True, agreed. And then push to hub is true because we want to add it to HuggingFace. Cool. The next thing we do is provide the trainer with a compute metrics, which I'm guessing we're using Rouge function so that we can evaluate our model during training. Okay. For summarization, this is a bit more involved than simply calling rouge.compute on the model's prediction, since we need to decode the outputs and labels into text before we can compute the Rouge score. The following function does exactly that and also makes us use the sent tokenize sent from NLTK to separate the summary sentences with the new lines. So we have compute metric, and then we take predictions and labels. We decode the predictions, and then we remove the -100 because they're not useful information, and then decode reference summary into text. What was that? Batch label. This time for label. And then clean it up, and then get result. So just a bit of pre-processing before we actually do the thing. Cool. Double checking that my screen is being shown because a few minutes ago it was not. Okay. I mean at the beginning of the stream. Yeah, okay. So do we just run this? Run. We have the data collator, we have training is here. I feel like I should just start training because it will probably take a lot of time. Okay. Remove column. And then just remove everything of the original, keep everything that's not from the original. And then, cool. I'm just gonna run these. And you give everything to the trainer and then you say, go. So next we define a data collator for our sequence to sequence task, since MT5 is a decoder encoder transformer model. One subtlety with preparing our batches is that during decoding we need to shift the labels to the right by one. Really? This is required to ensure that the decoder sees the previous ground truth labels and not the current or future ones. Okay. Which would be easy for the model to memorize. Cool. This is similar to how masked self-attention is applied to the input in the causal, in the task, like the causal language modeling. So yeah, we don't want them to see the future. We just want them to see the here and now and also the past. Luckily, we have thing ready that will dynamically pad the inputs and labels for us to instantiate this collator. We simply need to provide the tokenizer and the model. So here's the tokenizer and here's the model, collated for us, make it look nice. So let's see what it produced when given some examples. We need to remove the columns with strings because because it won't know how to pad these elements. And then since, we're just looking at 2 examples. It expects a list of dictionaries. Each dict represents a single example in the dataset. We also need to wrangle the data into the expected format before passing it. How? We're not doing any wrangling. It's just a loop. Okay. Here's the data. Main thing to notice is that the first example is longer than the second one, so the input IDs and attention mask of the second example have been padded on the right. Okay. This is the padding, all the zeros. With the pad token whose ID is 0, similarly, we can see that the labels have been padded with a -100. Here it is. There's one. Okay. Make sure the padding tokens are ignored by the loss function. Finally, we can see a new decoder, this one at the end, which has shifted the labels by inserting it at the beginning, so that, okay, thinking about the future and the past. Okay. We finally have all the ingredients we need to train, so we just give it everything and then we train. How long do you expect it to last? 27 hours. This is fun. And I've had cases where, like, at somewhere in the middle, it's like you ran out of hours on collab. That's also happened. So I don't expect this to work. No, you're kidding. This is not a checkpoint. Is it? Oh, you just created the things in case there are. So do not expect this to have an outcome, and if it does, then cool. During training, you should see the training loss decrease and rouge increase with each epoch. Once the training is complete, you can see the final one by running evaluate. Cool. So you went from, if I remember, going back to here, metric, baseline. We went from, nope, this is not rouge. Where's rouge? 16, the L or the L sum, somewhere around 15.62, that. And this one here, well, what was that? Huh. The difference is 1%. That's not much. Is that supposed to be good? Cool. For the scores, we can see our model has outperformed our baseline. Yeah, but like by 1%? I don't see that as a good thing. Final thing to do is push the model weights to the hub. Uh-oh. I forgot that. Okay. Yeah. And then you push to hub, and there it is. This will save the checkpoints and configuration files to the output directory before uploading all the files to the hub by specifying the tags argument. Oh, okay, to the hub dot. By specifying the tag arguments, we also ensure that the widget on the hub will be one for a summarization pipeline instead of the default text generation. Yeah, associated with the architecture. So we gave it a tag. The tag says summarization. Okay. So the output is a URL to the git commit hash. You can easily see the changes that were made to the model repository. To wrap this section, let's take a look at how we can also fine-tune the M5 using the low-level feature provided by Accelerate. That's cool. How much is that? Because my model is training, I can't really run any more code, but that does not mean training loop. It's all just code basically. Using, which means it's done. I'm just gonna go through it because it doesn't feel like long, and if it helps us learn, then that's something we can accept. But if it doesn't, then that's cool. Okay. Should I take a break? I mean, just not reading so much. I'm gonna take a break, which is a break, meaning I'll drink some coffee. Okay. Break all done. And check on this. This is going to take All right. I mean, yeah. Hold up. Cool. It said, I double checked to see how many steps there are, and it said 714. And now I'm looking at this. It says 5,000. Wait, did I? Yeah, 720, which that's steps, isn't it? Hmm. So accelerate, fine-tuning our model with the HuggingFace accelerate thing. Is it a library? It's very similar to the text classification example we've already seen before. The main difference will be the need to explicitly generate our summaries during training. So we have to like work harder for it, basically. And define how we compute the Rouge score. Recall that the sequence-to-sequence trainer took care of the generation for us, true. But we have to do that ourselves. Let's take a look at how we can implement these two requirements using Accelerate. Okay. So preparing for the training, assuming we have our data ready, what do we do next, basically? First thing we need to do is create a data loader for each of our splits, since the PyTorch data loader expect batches of tensors. We need to set the format to torch in our data set. So, okay, where we are is our data set is tokenized, and we work from there, which is basically, where was that in our, I'm guessing like right here, right? Before evaluating the baseline? Do we have something called a tokenized data set? There it is. Yeah, so right around here. Now that we've got data set consisting of just tensors, the next thing to do is instantiate the data collator for sequence to sequence again. I mean, it's not really again because you're doing it like for the first time. But the other one was using a different method. This is a different method. Yeah. For this, we need to provide a fresh version of the model. So let's load it again from our cache. So we're loading the main model, which is an MT5. We can then instantiate the data collator and use this to define our data loader. So we say data loader. I was not very young when I learned datum is the singular form of data. Yeah. So we have the batch size of 8, and then we give our tokenized data set, and then we have the data collator. Hold up. And then batch size. Yeah, okay, so we need to have this as well, where you have a data collator and you give it tokenizer and a model. Okay, good to know. And hi, hello, what's up? Peace. Aw, that's cute. Oh, I thought it's a peace sign. It's a wave. Bonjour. This is Spanish, by the way. It's using Spanish. There's nothing bonjour about this. How is hello in Spanish? I mean, I'm not saying you're Spanish. You're not. I know. I'm just saying. Do I know? I think I know. Yes. Okay. Did you have an exam recently? Or you haven't? I love the what's happening. I'm like, I need to know what's happening. This is we are fine-tuning a summarization language model on a different language. It's technically on 2 languages. It's a multilingual one. We did the trainer API part, and it's training right now, but it's not gonna finish. So don't expect it. It's going to take 23 hours, but I'm looking at the different method of doing the training more manually, which uses Accelerate. Did you? I do work on personal projects. Nothing that I do on stream. Yeah, and this Hugging Face is not finished, so yeah. Yes, there are personal projects that I'm working on that are a bit too personal. And then there is actually a competition that I have not registered to that I'm planning on registering, which is also like, if I do it, I'll have to register it under my actual name. So, yes. Can I don't know how public it is, honestly, because it's not like a part of where I work. Definitely not. It's a global one online. But I'm gonna maybe put it on Discord just so that, yeah, because I'm not sure. So Noir is currently avoiding the fact that I asked about their exam. I don't know. None of those. Yeah. What's there to challenge? The competition? I have no idea. Let me see if it's public, because I really don't know if it's public. Or maybe it's like very niche. 2024, because it was on a government website. Thing is, the title is very generic. I can't find it on Google. Like, I have the link because I got it by email. Oh, it's in February? Wow, that's cool. I'm glad that you have time to study for it. That's actually really nice. That's nice. Yeah. I think, I don't know how many people here know that I applied for a PhD program in 2023, and then the program closed. They, on their website, they said that they're opening it again this year, and then they are accepting students, and I think they didn't open it again. So I'm seeing it as a blessing in disguise. Because if I had a PhD program with a full-time job, I don't think I would survive. So yeah. Aim is to finish 60 to 75% of the syllabus by November 15th, inshallah. That's cool. Are you in contact with any of the people there? Because even if you don't know them, I suggest emailing some. I don't know if I hope to get shortlisted for the PhD, because I really don't want to study at a local university, even though I like the people, and I will probably feel very comfortable. And I cannot, I have a full-time job. I cannot just uproot my life and go study somewhere else. Life is so hard. That's cool. Online coaching. Good job. Wow. that's good. Just knowing someone who's been through it is actually really useful. I used to like help people out after I finished my master's, so yeah, but not too much. I took an online personality test. Is it called the MN something? And my last test stream? No, test stream is all done. Does it say test? Uh-oh. Darn it. I checked the title. What's wrong with me? It's not a test stream anymore. I should update the title. Let me update the title. Oh God. What was I saying? I took a course. No. What was I saying? Not a test stream. Test stream all done. But thanks for letting me know that I forgot to update a title. No. Oh, yes. Thank you, IT Solutions. Honestly, your timeline is very well prepared if you can, if you don't procrastinate too much. Because even like there are times where I make myself a really good plan, and then I do half of it, which is great. But I hope that you can do all of it. This is not a test stream. Test was done yesterday, and isn't the by the way, I'm using the thing called screen copy, which sounds like Yippee! Yes. Yippee. That's funny. Wait, what? No. Oh my. Why didn't I get why didn't I get notified? Twitch. Why didn't you notify me? Wait, who followed? When? Oh my God, thank you, IT Solutions. Wow. And I got a hydrate notification, but I didn't get it? Why? I didn't change that much. Things. Oh, sorry. Aitsuki, I really didn't see that one. I will hydrate though. Huh. Thank you for the follow. Thank you so much. I just didn't expect not to get the notification, and now I'm mad at Twitch for it. Thank you. I didn't get any of the notifications, meaning I have a problem with my setup. I will try to solve it. But I got the Yippee, which, it's cool. It's cool. I'm not too mad. I hydrated using coffee. Is coffee hydration or dehydration? I have no idea. Oh, that's so cute. Yeah. Thank you. Why PyTorch? Why not PyTorch? I don't have a reason. By the way, actually this thing, course allows you to choose between PyTorch and TensorFlow, I think. Wow, this is dizzying. Yes, TensorFlow or PyTorch. So Leonardo, hello, hi. I think you're a first-time chatter. You don't have to. It's not forced, but I prefer PyTorch. Because I'm guessing it's more loved. Am I not? Like it's more used by people. There was a train of thought that I wanted to finish, but then I didn't. Where was that train of thought? Help me. Take me back there, someone. Yeah. Good luck on the learning, and Noir will now go and study. People, let's say good luck, Noir. Because they will go and study, and we will. By the way, Noir, this is me studying. You know that, right? So we're in this together. Yes. And yeah. Trying to find my train of thought. If all goes well, I might try for a distance learning PhD at least. No one likes PyTorch. Is your name no one? Really? What is what really? Which part really? Pharisology? As in like, I'm guessing someone's name is Faris instead of the language Pharisee. Yes, really. Definitely, for sure. Yeah. There are far more first time here. Ah, thanks. Cool. Hi. There are more master's programs that are online than there are PhD programs that are online. Because it's 100% not recognized in my country. So that's fun. And I was like, you know what? I'll start anyways. And it might get recognized in the meantime, you know? Also, I don't plan on working. Well, what I heard was even if you don't plan on working for the government, even if you do like try to teach at a non-governmental university, you still need to be recognized. Cool. The oology to make a cult. Oology does not mean cult. I follow a podcast that's I think it's just called an oology. It's not cultish. It's about the study of, right? Because the thing about oology, I know, what is it? There's astrology and then there's astronomy. And astrology means the study of stars, but the name is stolen by, astrology. And yeah, okay. There. Thanks for tuning in into the live. We normally study here, and that's what I'm trying to do. But also we sometimes look at tutorials and lectures and stuff. So that's how we're trying to learn. Been doing AI before TensorFlow. That TensorFlow was 2015, wasn't it? The dark ages. Wow. What I see is today research work built in PyTorch, Meta money and support. Oh yeah. I mean, fair. I think that's the Facebook AI research lab or something. I'm guessing PyTorch was not made there, but still, Meta and Facebook is putting a lot of resources into research and creating tools and stuff. I think Microsoft is doing a lot of that as well. But like, I wouldn't say up newcomers like OpenAI, but those benefit a lot from the tools that are built for them, which is pretty cool. PyTorch has a better setup for researching. Yep. There's a lot more support behind it. For example, like I was a bit, like just, I made myself choose between Python and R when I started my, my master's program. That was like a bajillion years ago. But then, which I chose Python, but then I learned, R anyways for work. And that has a lot of support behind it as well. Oology from Greek means knowledge, so it basically means things that sound like a field of science. Yeah, study of knowledge. That's cool. I don't know if it's pronounced oology, but yeah. The podcast is pretty cool though. More of a practitioner, so we don't really like, what do you use? Let me know. Because I just use what other people are using. I don't consider myself a person who's well versed in, even though I've been on the sidelines. I haven't been a practitioner for long, like maybe a few months, I'd say. Mostly hobby related. Yes. Which is why I'm trying to create a good base for myself to learn stuff. Okay. So my plan was to do this read through this for the next few minutes. Writers gaining ground, LLMs are mostly fine-tuned. I know. I know as in I agree with you. When like state of the art stuff or standard stuff is made in a language, then you are somewhat forced into using that. So yeah, more TensorFlow. Cool. I'm guessing they're very like possible to convert between the two, right? I don't think it's that hard. Computer vision frameworks like Detectron and Detectron are built with PyTorch. I see. I don't have enough information about computer vision. I just know that I like Dr. Feifeli. Yeah. YouTube has been recommending a lot of her recent interviews for me. And I actually enjoyed one that was with why did I forget his name? Why did I forget his name? The guy who won the Turing Award. Not Jan LeCun, but the other one. Anyway, there was a interview that I really enjoyed. I'm agnostic. Okay. Work more on medical imaging. Ooh. you pick whatever that gives you a good recall. Yeah, that's cool. Honestly, I've been using a lot of LLM supported, like help when I try to run things, especially Claude Sonnet. I really like it. Was I here? No. No. I think I was here. Easy to find on next V2 implementation in PyTorch than in TensorFlow, because a lot more people use PyTorch, I'm guessing. But TensorFlow came at a good time and did a good job with what it was. I actually remember the day I learned about TensorFlow coming out. I was in class, and I showed it to my I guess he was a lecturer. I was like, look at this. Good times. I was definitely too afraid to learn it. I was like, this is not for me. I'm not smart enough. And look at us now. I'm still not smart enough, obviously. What do you expect? But I will try to learn and not use it as an excuse. Yes, I absolutely love Claude. I use it way too much, especially for coding related stuff. Because I was testing ChatGPT on the stream the other day. When I use ChatGPT, I use it for more like help me with this that has nothing to do with coding compared to Claude. Like for Claude, I use the free version, which is limited, but it's really useful. Yeah. TensorFlow liberated me from, I don't know what that is. Theano? You have a huge debt, and so you're talking about the dark times that I have zero information about. My knowledge is goes back to that time. Like mid 2010s. Before that, I was probably I was still a uni student, but I didn't have enough information to look into this stuff. PyTorch brings us options. I think we are more likely to. Oh, I don't even know about Cafe or others. I know PyTorch and TensorFlow and I don't know if, yeah, then you move out of Python. Yeah, there are non-Python solutions as well. But yeah, mm, it's cool though. It's cool that pre-2015 piano, how do you read that? Was the way to do deep learning. Was it even deep learning? I guess it was, because AlexNet was before that. Okay. It was a pain to set up or code or debug. Ooh, wow. Respect, man, respect. Since you've used those stuff. Wow. Why are you even here? I know nothing. Wow, that's cool. That's very cool. Ah, you make tutorials. That's awesome. You haven't had any content in the past 6 years. Cool. Um, wow. Machine learning in Arabic. That is awesome. Wow. You have a nice following. Um, I hope that you can continue. I mean, if you feel like it, you don't have to. I do have a Discord channel. Fine tuning a GPT model for data science and ML works. I think it's in the descriptions, but I can put it in the chat if it works better. Let's see if I can find it. Link to Discord. There we go. Yeah, a lot. Let me know if this link works or not. Our Discord is a bit quiet because I don't like bothering people. But if you ask me anything, I will do my best to answer you, even though I don't have answers, you know. But you know, yeah. Mm, okay. I think I'm gonna leave here and come back to it during the next stream because this is like, if I go back to it, my brain will not accept it. This has been training for 35 minutes and we are 0.22% close to 1 epoch, which there's zero chance of this be even finishing 1 epoch during this stream. I can be here for another hour, I think. We'll see. I don't have to, but still. Only able to do deep learning because TensorFlow, I lowered the barrier. You're right. You're absolutely right. I also learned PyTorch late in 2019. Ah, only started using it at work this year. Uh-huh. Yeah, you're right. But I will say that even when I try to learn languages or tools for work, now with stuff like, you know, ChatGPT and Claude, Sonnet, and I don't know if there are other tools, maybe Copilot, like the barrier of usage of a tool has lowered even more. But you'll still need to understand what you're doing. But you don't have to memorize stuff or like look up stuff far more. Thank you. That's very nice of you. For joining Discord. I will promise not to bother you. Hmm? Okay. Yeah. So, oh God. See, thanks for this. Thanks for subscribing. Why am I getting a YouTube notification but not a Twitch notification? I am very sad right now. I will make sure to fix the Twitch side issue. Yeah. Okay. Thanks for the. There we go. Cool. Thank you. Will do my best. I also like engaging discussions and conversations because, yeah, it's not, it's easy to find the people that have similar interests, but it's not so easy. Like there are way too many people on the internet. So, yeah, feeling alone in a crowd happens easier than you think. Mm-hmm. So finding people that are have similar taste and want to have similar goals, that's cool. So this lecture, which I think I'm gonna try to go through it for the next half an hour, is about these stuff: distillation, quantization, and pruning. And we were talking about, what were we talking about? Distillation? Yeah. Making a model smaller, that does the same thing. Where is the size written? I don't see it. Oh, there it is. Yeah. Yep. But there are actually really good examples of distillation working well. Let's see. Why is it quiet? Oh, okay. I guess I stopped on pruning. Okay. What is pruning?
Okay, so pruning is pretty different than quantization. In quantization, you are sort of like chipping away at every parameter in your model. Instead, in pruning, you're like completely eliminating some parameters and completely not changing everything else.
Like, is pruning the thing that is used for trees where you cut off branches? That's interesting.
So a number of parameters set to 0 and the rest are completely unchanged. And the most intuitive way to do this is this idea that if you have a bunch of parameters, some of them are probably close to 0, in which case they're not doing anything anyways. So just make them completely set to 0. That way you can ignore those parameters effectively. They effectively are not doing anything, and it's as if they don't exist. So in magnitude pruning, you set to 0 some percentage of parameters that have the least magnitude. And in like machine translation, people have seen that you can remove almost half the parameters in a model and get almost 0 change in your downstream performance.
Okay. Sounds like similar concept, but interesting how nothing changes. Yeah, you're basically taking away stuff that's making it heavy but not useful. But I mean, problem would be, how can you find the thing that's making it heavy and not useful? Yeah, there are really interesting research that's happening that I have like zero information about because it's just, I don't know, like sometimes the concepts are easy to understand, but sometimes they're not, and implementation is always difficult to understand. I don't know if Coffee's here, but like the amount of information they have is really helping me understand stuff more. Yeah. How do you identify those? Let's see if they share any methods, because normally they do. So I'm guessing like maybe a quarter of this lecture is about that subject. By the way, this is a lecture series from CMU, Carnegie Mellon University, taught by Graham Neubig, although the person talking is not Graham Neubig. And this is lecture number 11 of the spring series. There's also the, and someone's lurking. Hello. I'm just saying you help me become smart. Which, if there is any failure, it's my fault, not you. And that you have far more research related information than me. Which I utilize. Yeah. Yeah, there is the fall version that came out a few weeks ago. I watched. Server invite link is expired? Oh no. Let me create a new one. Invite people. I thought I had it at forever. No limit. Yes. Or maybe not. Create a new link. Copy link. Put it in the chat. Here you go. So what was I saying? I was saying that I'm gonna play this now. Oh yeah, fall version, spring version. I watched lecture 1 recently on my own because I was like, it doesn't make sense for me to rewatch the same lecture on stream again. Like I'm too much. I don't I don't see any comments from Coffee. I guess they're still lurking. Okay, play.
Machine translation, people have seen that you can remove almost half the parameters in a model and get almost zero change in your downstream performance, which I think goes back to the earlier point about over-parameterization. Like you need a lot of these parameters for training the model, but in practice, they're not really doing too much. And so you can just get rid of them. And so this is a type of unstructured pruning where you're just, you're removing parameters throughout the model anywhere you see fit. There's no structure to how you're doing the pruning.
2 points. I guess you're just cutting things as you go. That's unstructured pruning. Second is you need it for training, but you don't need it for using the model. That was an interesting thing that I don't understand what it means, but is interesting.
And this is related to the lottery ticket hypothesis, which was this idea that when you train a full model, there are like randomly there are subnetworks of that model that
thanks for the subscribing. I'm like, thanks for the subscription. No, that sounds weird. Thank you for subscribing. If you're here, say hi. If not, that's cool. Recommending a manual search, I guess. Let me play again.
There are subnetworks of that model that
Is a student talking? Because this is an actual lecture. Lottery ticket.
The idea is that when you're training a big model, there are subnetworks that are actually a better initialization than the initial model. So it's a little bit unintuitive that if you have
not really, but over parameterized networks for training. I don't think I remember it, but I get where you're coming from. Implies you train those more. Oh, okay. So you train with more parameters. Then one thinks they should ultimately need. Interesting. Okay.
Let's say a model with 100 billion parameters. There's subnetworks of this model with, even if you randomly initialize them, that might say have 1 billion parameters, like 1% of the size, that are actually better than the full model. And so this is related to pruning, but here they prune the model, then they retrain it, and they find that surprisingly, like here, a model that is 20% the size, so it's pruned to 20% of the original model's parameters, and then retrained, is actually like more effective and generalizes better than your original model. So the idea here is basically finding.
That's so cool. But here's a question. Can it be 100% pruned? Does that even make sense? What is this percentage? Because this 20% was 20% pruned and does a better job? Or is it, oh, does it mean this is 100% of the model actually itself? And then this is 50% pruned? That is very interesting.
Like really good initializations of these subnetworks can be better than like the most intuitive random initialization of a big model. And so this is sort of a step beyond pruning, where you're pruning a model, then training on top of that, and that can improve performance. But generally, pruning, I think, is not a method to improve performance. It's a method to maintain performance while improving the efficiency and the size of your model. And so there's been like a lot of cool work in pruning coming out of CMU recently. This paper called Wanda, which came from folks in MLD. The idea here is that magnitude pruning presumes that you can just decide which parameters you want to throw away based on how big they are, but it doesn't consider the fact that there are systematic differences in the size of inputs that come in. So in the paper, they gave a nice example, which maybe I'll write on the whiteboard here, which is that.
We don't see the whiteboard. They're not sharing the whiteboard. So I will talk over them while they're quiet. Should I? If I go forward.
Two parameters.
Okay, there we go.
If let's say your model was just this basic 2-parameter model, X and Y, and you had weights A and B. And let's say we know that the magnitude of A is like a lot bigger than the magnitude of B. Then in magnitude pruning, we would just set B to 0. And then the model would just become A times X, because the idea is that this parameter has a lot more effect on the output, and therefore we don't need to consider the other one. But what if I told you now that the range of X, like the average value of X, was 1,000? The average value of X was 1, and the average value of Y was 1,000. Now, in practice, even though B is smaller, it's processing much larger inputs, and therefore it's going to have an outsized impact on the output of the model. So that's the motivation of Wanda, which is here they decide which parameters to prune based on a combination of the magnitude of that parameter, as well as the magnitude of the actual inputs that come into that layer of the model. So they take like data, calibration data, and then they kind of say learn what the average magnitude of the inputs are, and they use this to decide what parameters to prune.
Average magnitude. Okay. I mean, I definitely do not understand what they're talking about, so.
Okay, so so far I've been talking about unstructured pruning, and I think there's a pretty clear problem with this that makes this really not that effective in practice. And the problem is that you can make a model sparse. You can take the vectors and make them sparse. But if your hardware does not take advantage of that sparsity, then you're not getting any gains in performance. So for example, here we like turned off half the parameters. But if we're still multiplying zeros with other zeros in like a dense operation, we're doing exactly the same amount of work. We're getting no benefits here. And the reality is that right now, hardware for machine learning does not support sparse data structures or computation that well. Like matrix multiplications do some kinds of complicated things under the hood. And therefore, they don't really work that well for sparse data structures. And so basically right now, this is not very effective in the current hardware, although I hope this will change in the future. So therefore, like a more immediately useful idea is called structured pruning. And the idea here is that instead of just picking parameters across like willy-nilly across the whole model, you remove entire components or entire layers.
Ooh, removing layers. Finding the relevant weights to finding the that's why it's called a lottery, because it's not easy. Yeah, 1 in a million. Well, NVIDIA added support for structured sparsity in the really 30 stuff series. I don't have information. That is very interesting.
And therefore, you're pruning the model in a way that is structured and really going to make a difference on your overall runtime. So Graham and one of his PhD students a few years ago did some really cool work on this, where they
How cool is that? The lecturer is like, oh, look at my research. It's a part of what I'm teaching you. This is cool. I hope to become that lecturer someday. But again, lecturers don't get paid enough, and I am running after money, so not today. Definitely not today.
showed that if you're training a transformer model like BERT, you usually have many heads of attention. Like you guys also experienced this for the Llama homework, where you had, I think it was 8 heads of attention there. But in practice, most of these heads of attention can be removed without really any negative impact on the performance of your model.
Okay.
And so here they show that for an MT model, you can remove half of the attention heads entirely and get a negligible impact on your performance. This is different than what we showed here, where we were removing parameters from anywhere in the model we saw fit. Here, we're removing entire heads of attention. Even some of those heads might have large magnitude weights, some of them might have small magnitude weights, but we can just remove the entire attention head, and this has an immediate impact on the performance of your model.
So regarding structured pruning, we saw the removing a layer, and now we're talking about removing a head. I don't know how that would work, because I don't know. Like, are attention heads like a variable, something you can just remove?
Model.
Cool.
And generalizing this, recent work has proposed controlling even other kinds of components of your model. So in this paper from 2 years ago, they propose masking, having 2 levels of masks on your model. The first is like what they call a coarse mask, which is turning off large components like full attention heads or full feed-forward layers, where you replace them with the identity matrix. And these are like really big things to turn off. And then you could also have fine masks, like sorry, I meant entire self-attention layers, not attention heads. And then the fine masks would control like individual heads or removing individual dimensions. So changing your.
It's more for MLP layers, which is where most of parameters are anyway. Cool. What is MLP? Sort of forget about the attention layer, maybe. Okay. 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 But like, you should be able to pick and choose at least. You can't just forget about the attention layer as is, like everything. I don't know. I'm trying to there it is. Trying to visualize the transformer graph, and there are definitely multiple just this, like in different places. Even if it's a multi-head attention, it's in different places. Okay.
Your hidden state to be from like 512 dimensions to 200.
Missed this slide. He's mentioning attention layers too. Okay, yeah. Dense layers or multi-layered perceptron. Okay. Yeah. Cool. Yes.
changing your hidden state to be from like 512 dimensions to 200 dimensions. And so the idea here is they give two different levels of granularity at which you can turn off different components. And then these masks then learned using some kind of held out validation data to learn what can we turn off without like totally destroying the performance of this model. And in this paper, they showed that you can really get pretty far with this idea. And the last thing I'll say about pruning here is that methods like this, you're actually learning a kind of control over your model. So you're learning this set of masks.
Multi-layered perceptron is like one of the, perceptron itself, not the multi-layer part, is like one of the first neural network like algorithm stuff model. I don't know about fully connected networks, so Coffee may be able to answer that. But yeah, we had a AI subject during my undergrad, and we learned about perceptron and backpropagation and stuff. It was fun. I don't remember anything though. Dense feed forward. Okay, I have heard the word feed forward. Cool. Ooh, we talked about backpropagation at the same time. Cool. Oh, I see the word feed forward right here. I don't know.
Control over your model. So you're learning this set of masks, and that's pretty expensive in terms of training budget. It requires a lot of GPU memory. And so if you want to prune, let's say a Llama 70 billion model, you'll need basically as much compute as it took to train that model to begin with. So this is a recent paper from Graham and one of his PhD students, where they instead ask, can we do pruning without having to like compute gradients at all? So basically, if we just have enough memory to run the model on our computer, can we then use that same computer to prune the model without having to use Atom or to compute gradients? And so I think the idea here is really clever. They basically randomly mask out all the different modules in the network. So they like create like 100 or 1,000 variants of this model with different masks turned off. Then they measure the performance of those like perturbed models. And then they learn a regression of like how much does each module affect the performance of the full system.
Modules. Okay.
And then you can then use these regression weights of this learned regressor to figure out which modules you can actually turn off without impacting the performance too much.
This is 2024.
Okay,
the paper is 2024. Wow.
Questions here?
Just doing like a validation forward loop on these prune models?
Yeah. Like randomly prune models.
So remove our model. What happens to the matrix multiplication part? Do you just multiply with identity instead? What is it?
Yeah, that's right. Like it depends on I think like for self-attention heads or for feed forward layers, you could think of it as just multiplying by the identity. And next I'm going to move on to distillation. If there's any questions about anything I've covered in pruning, you can ask now. And I know I was moving pretty fast, so.
Okay, so the first part was quantization and then pruning and now distillation.
I'm happy to talk.
What's the point of learning or regression? Does it generalize to other models at all, or what's the purpose?
Yeah, the idea is that, so the best way to do this would be to consider all possible choices of masks. Like turn off every combination of modules and then measure the performance. Then you know exactly which combination is the best. But if you have tens of layers and tens of components in each layer, you'll have like millions of different submodules you want to try out. So this lets you just sample from that space, combinatorial space, and then predict the interaction between what you have seen, between the modules based on what you have seen.
So like slightly more optimized than some kind of random search.
Yeah, I think that's right. Yeah. I think you can make an analogy for this to like parameter selection, where you can do random search, but now people do much like fancier things like Bayesian optimization, which are trying to
Beijing. That's funny. There's backpropagation, just no loop compared to RNNs. Really? Okay, so that's for. Are we talking about transformers? Because yeah, I guess I have information, but I can't really answer questions sometimes because I don't know. I don't have enough information. Yeah, the YouTube closed captioning captioned Bayesian to Beijing.
explore the space in a more structured way. And so I think that this is similar in spirit.
Do you know the plot trees like the so are you like randomly just choosing like for example the green one does better it seems. So is it just like you're retaining 80% of the parameters randomly? Like
You're retaining 20% in the green line. So you're throwing away 80%. So in the like what this green line exactly means, and I did not go into detail here, is that you first train a full model with all of its parameters, and then you apply pruning methods, kind of like magnitude pruning I showed before, to find like a good subnetwork that is still pretty effective after training. But then they do something weird, which is then they then restore that subnetwork to its initial random initialization. So in the beginning,
FNNs? I don't know. What is that?
you had in the beginning you had
They're writing on the board and we can't see it, so it's quiet. Okay, I'll need to go.
model, and you get
Okay.
So you train this model, and you initially initialize it randomly. So you might have just random values at each parameter. You then train the model as it is. So these parameters are all changed, and they serve the task. Then they identify a good subnetwork here. So you might throw away this node, you might throw away this node, maybe this node. And then you say, okay, what was the initial initialization at these exact parameters, which I've since learned.
Feed-forward neural networks. Okay. Okay. Yeah, I guess. I don't know, because of Transformers, my eyes cannot see anything, but I'm guessing that's a part of Transformers. I don't know, honestly. Just learning as I go.
I've since learned better parameters, but what was the initial value here at the start of the optimization process? They then go back to those initial values, retrain the model on this task, and it becomes even better. Which I think it's there's been a lot of like theory about this since this paper came out. It was kind of like a very influential paper. I think to me, this shows at the very least the importance of initialization and how much like randomness there is in neural network training, and how you can kind of take advantage of that.
Okay.
Yeah, how is that related to dropout?
Someone asked a question.
So I think you can see dropout as a version of pruning where at each step of optimization, you perform a random pruning. You like randomly prune your network at each.
Yeah, we've heard about dropout. So it's a type of pruning, I suppose.
For each update, and then you then you update the parameters that have not been dropped out. But then in the next step, you have a totally different prune network. So here you're doing pruning once, and then you're training this fixed prune network for all of the iterations. Whereas in dropout, you're doing like a random pruning each time. And they serve different purposes is the main difference, where pruning is primarily for reducing the size of your model, whereas dropout is primarily for regularizing your model to avoid overfitting certain, like to individual weights. Like to avoid individual weights having too much correlation with the label.
Okay.
Okay, so I'll move.
Yes, they do. There are way too many terms. I agree with you. Like literally something that it's very, yep, agreed. Something that I tell beginners is like, don't be afraid of those like things, because even if you don't know much, if you watch a few tutorials or read a few things, and then you learn some of the keywords, then you're like halfway in. So sometimes the barrier is actually the things that are behind those jargon words. So I agree with you. There are way too many things that say the same thing but in different ways. And it is confusing for a big percentage of the people, and also people who are coming in. But I suppose that they're there for a reason, but still, it's still annoying.
Move on now to the final piece here, which is yeah, so the last slide I forgot to show here is that, which I think is a kind of a summarization of everything I've taught so far about pruning, is that Wanda, which is this unstructured pruning way that I showed earlier, even though it achieves the same number of parameters as like a structured pruning method, which is Bonsai, the one from Graham, it actually.
Oh my god, this is such a cute name. Bonsai? Is bonsai the name of the model or the pruning method? Because I'm guessing it's a pruning method because it's llama and it's pruned. Like, he likes Japanese, he knows Japanese, so that's one reason. Second, bonsai is a type of tree and pruning has to do with trees. How cute is that? That's cute naming. And bonsais are cute, obviously.
Achieves much less of a speed up, potentially like a negative speed up.
Oh.
And whereas a structured pruning method.
Oh my god, it's raining. I'm gonna die. It's probably not gonna last for long, but it's raining. Oh my god, I love rain.
With the same amount of parameters can be like a lot faster. Like 50% speed up is huge. So I think that this shows that like unstructured pruning can be pretty ineffective if it's done naively.
Okay.
Okay, so now I'll move on to the final piece here, which is distillation.
I'm out. That's it. I'm not gonna start a new topic. So I'm gonna plug that in.
Distillation.
Chill. So that we can come back to it during the next master's program. Treated weights and biases as theta 0 and theta 1. Why? Pruning being close to dropout. Yeah. Why though? That's very annoying. Bonsai is like a pruning method even for trees. I know. How cute is that? Wait, what? It doesn't have to be doesn't have to do with bonsai trees? Any different species of trees can be bonsaied. Oh, bonsai tree is a smallified tree. I thought it's just a type of tree. Huh. Good to know. Ah, that's interesting. Okay. Still not even halfway through to a full epoch, and we've been training it for more than an hour. That's cool. Oh yeah, universities are like very good at being annoying. I can tell you that. Although some of I guess the university as an entity is more annoying than people are inside are nice. I like people. Okay, so this may come as a surprise, but another thing that I watch during these streams is this linguistics course, because it's fun and it's just a 10-minute video, so it's not going to be yeah, because I don't have like another 20 minutes or however long this is, more than an hour. Actually, half an hour, more than an hour. See you next week when you're done training. Yes. I don't think I will ever be done though. There's always more to learn. But I think I'm gonna watch this video and probably end the stream. Because yeah, there's another like 15 minutes that I can be here. Yeah. This is my routine.
Hi, I'm
Hello. Yeah. I was planning on updating my streaming schedule to make it more sustainable, because every day is definitely not a good schedule having a full-time job. So, surveying online masters, are you doing? Ooh. So here's the thing. I actually, when I first wanted to do my master's, I applied to an online master. Oh, done with the epochs. Ah. No, it says another 19 hours. It's not that long. Don't worry. Yeah. 19 hours. Yes. So I applied to the Georgia Tech Online Masters and got accepted, but I chickened out and didn't do it. I did a local one. But I don't think I plan on doing another online masters, even though I'm applying for a diploma. Sorry, an online diploma. If that counts, then yes. I have not applied, but I'm planning on applying to an online diploma. If that counts, then sure, shoot it my way. But like I said, I'm more interested in distance learning PhD programs, which there are a few, I think. Like, there are way too many names. For example, Split, there's a thing called Split something. I think Australia does a lot of that, or maybe Malaysia, I don't know. And then I think Australia has something called offshore learning, which is basically distance learning, but for, I don't know, people that are not close to the shore. Yeah, I've done a lot of research on that front and haven't got anywhere yet, but maybe someday. So yes, please do put it on Discord or somewhere, or DM me on Twitter or something. Do I want to teach? The answer is not a no, but not now, you know? I was saying the other day that when I did temporary teaching assistant, I was basically almost like very close to age to the students, and I think it's not no, the split is not skipping masters into a PhD. It's what is it called? Is it just a split PhD? The split is you do, it's not a double PhD, but you are under supervision of two different split sites, something like that. Like Imperial College London has it, apparently. Split PhD. There's a word, just a split PhD. So you do half of the learning in your split PhD scheme allows you to carry out some of your research abroad, either in the field or over at an overseas institution. Yeah. So it's half-half. Yeah. So here it says, yeah, I am reading this right now. This thing. There we go. Split PhD. It has to do the word site somewhere I saw, but I don't see it right now. Yeah. There are different ways. The split one is recognized in my country, but the distance learning one is not recognized in my country. I don't care. I wanna do research. And then I procrastinate when the actual time comes, and I'm afraid to do research. Anyway, what is the other one? There's a York University, not the Toronto one. And then they have a distance learning program module stuff. Let me find it. If all goes well, I want to apply to this one because it's a pretty well recognized university. But really, thing is, Leonardo, sometimes I don't know what you say when you're asking something because I've gone way too far when I talk about one thing. But yes, really. Oh, you said probably you're saying about the split being recognized but not the distance learning one. Yeah, really. Yep. My country is cool like that. Is that the York one? Yeah, that's the York one. That looks really fancy. They have distance learning for all of these stuff. Can you believe that? Wait, and you can even do part-time, which I think becomes 6 years, which actually is not that bad. And that's a PhD. They have the masters as well. Oh my God, this is cool. Computer science with AI, masters. All of these are online / distance learning, which is very interesting. Like they've had this for, I think since could be 90s or 80s. I might be wrong. They've had this for way too long, which is really interesting. Yeah. Like they didn't do this because of COVID, because a lot of other places did it because of COVID, which means they have structures in place that help students. Yes. I want to see if I can find the Wikipedia about this because I learned that they've had this for a while. There. I might be wrong. Distance learning. Let me see if I can find it. Distance. No? I guess not. Anyway, I can't find it. But they've had it for a while. I might be wrong though. I was comparing UT Austin and Georgia Tech. Yeah, Georgia Tech one is crazy. I want to go through my basics and get solid while earning a degree, not like certificate will boost my income. Yeah. Yes, the Georgia Tech one I can like get behind fully. I love Georgia Tech for I don't know why. Yeah, but like there is a forum, the Reddit, all of those have a lot of information about the Georgia Tech one. I've watched way too many YouTube videos about people who either have took or are currently taking when I was watching them. Hello Noir, what's up? Noir is also preparing for a master's program. We're talking about master programs. And yes, we're not jelly. But I don't have enough information about the UT Austin. I don't think it matters, but is there a difference in ranking? Does that matter for you? Doesn't have to, but I'm just asking. Yeah. There's also the interesting part about some countries where master's and PhD program are just smushed together. That part is, I don't know, I don't like it. Just having the freedom to do a master's without worrying about a PhD is definitely easier. Yeah. But from what I know, the Georgia Tech one is not easy, but has a lot of amazing people. Yeah. Who teach. Like I follow one of the instructors on Twitter. Yeah, because he's cool. There's a video series I watched by a person who was just like going through every course and what you expect, what you study, what grade they got. I don't know if you've seen that one. If not, I can probably find it for you. That's a no life situation for some people, but some people do. Oof. The thing about doing the master's and PhD together is, I don't know, like, because I did my master's while I had a job, so I could, make money and pay for my master's, which was not free, but my undergrad was free. So yeah, just like not being able to enter the workforce and doing more studying is probably a bit damaging. But like whatever works, Maybe you have the support, financial support at home. I have no idea. Yeah. Usual people who take PhD here in US become teachers. Not in my case though. Wait, are you a PhD student or something? Because I think I was about to answer you said here in the US, so hi, hello, you're from the US, so it's probably really late, you should go to sleep. I am from and live in the Middle East. Whenever I tell someone or someone from the Middle East, from the United States knows where I'm from, they're like, oh, I'm sorry. I'm like, nah, it's not your fault. So, hi. Also, anyway, I do want to teach someday, but not right now because teaching does not make the same money as, other work in tech. Like working in the tech industry makes you far more money than teaching. I think teaching would be my retirement plan. Oh, you're not? Okay. Cool. All right. I'm going to play this, but you guys can chat and I will do my best to answer you because I like engaging with people who watch my streams because I don't want to, yeah. There we go. 42. Is the study session done for today? This is more studying, by the way. How can you call crash course not studying, huh? A lot of good friends in Morocco, Algeria. Oh, you're not in a PhD program. Cool. Okay. That's cool. You said in my case, I thought that's why. Just came into chat and didn't know. Yes, this is still studying, but I am chatting as well. I think it will be done in maybe 10 minutes. We'll see. Let's see how long this video will take me. But I will definitely need to go in 20 minutes. If I'm not, then, I'll lose breakfast. I'm kidding. I won't, but still. Yeah, okay. There. I was just saying Morocco and Algeria. Yeah. Morocco is Maghrib in Moroccan. There. Flaunting my pronunciation. The end. Okay. It's pursuit of knowledge that you like, but without ruining one's life. I agree with you. Learning at a comfortable pace while earning money, working in tech. 100% agree with you. I do not want to be outside of academia for too long that if I want to go back, I will feel lost. But also, yes, it's early morning for me. Yes, it's GMT +3. Yes, you're right. GMT +3 is where I'm at. Although Sometimes we become GMT plus 2 because we don't have daylight saving time. Yeah, I think even if I did a PhD, I'd probably might do part-time because I want to make money. There we go. Oh no, it's 2 a.m. You know what? Please try to fix your schedule. It's not healthy. Like, as a, I guess I can say as a plus 30% in age, I can't. I need a good sleeping schedule. Otherwise, my whole body will kill me. Like as a teenager, it was possible for me to sleep late, wake up early because of school and stuff. Not anymore. Iraq, that's the name of the country. It's actually not Friday, it's Saturday. But still, it is the weekend. For you, it's Friday. Okay. All right, got it. That's cool. A lot of people in ML are rather like not as young because they've been in, like, even me, I'm not that young. So yeah. It's the weekend for me and it's the weekend for you. So cool. I'm gonna is it flaunting to say I woke up at 6 a.m. today? Because morning prayer. Yeah. Yeah. I try to have a good sleeping schedule because it keeps me feeling good. Yeah. Without sleeping at least 7 hours, my body, plus 30 cannot work. So the flexibility of working in the tech has made people in tech sleep in, which is not a good thing. Trust me. Yeah, but I don't know. Because even like my colleagues at work, they're like, oh, I slept at 2 and 3 yesterday. I'm like, why do you do this to yourself? Whatever you do at that time, you can do it in the morning. Like whatever it is. There are times where I've woken up at a decent time and watched a movie. Who cares? It's the same thing. Whatever you do at night, you can do in the morning. That's it. That's my only advice. Oh my god, I'm watching the video without sharing my screen. This is dumb. Sorry about that. You can sleep till 9 and go to the office at 10. That's actually true. Which I suppose 9 is not sleeping in. It's pretty decent. Thank you. Thank you, Leonardo, for joining us. Have a lovely rest and have a nice weekend, and see you next time if it's possible. However works for you. Don't do that. All your office, coworker do. You just feel safe. No one will come after me if I did. Yeah. Okay. Yeah, that's actually a good thing to feel safe about. I also tried to go to the office at a reason. Well, no, I go at the time where I'm needed to be there. I will not go in earlier because I like to, there's a limit and I'm not going to cross that to work overtime. Nope. Unless I'm paid for it. I just realized I was watching this video without you guys seeing it. Sorry.
To better understand the complexities of meaning, let's start with the humble definition, a clear and concise description of how people are using a word. Definitions are what we're used to reading in dictionaries and help us see when one word has a certain type of relationship to another word. For example, several words can have about the same definition. They're synonyms, like happy and glad and joyful. Two words can also have the opposite definition. They're antonyms, like inside and outside. One word can refer.
When I learned the word synonym, that was really useful. Still couldn't join. Oh my god, really? Huh. It's annoying. Let me see if I have to paste it directly here. What is that? Oh, sorry, wrong link. Where is the link? Where is the link? Here is the link. Copy. I'm gonna paste it, and then I'm gonna try to join incognito to see if it works. It does. Yeah. For me anyways. Maybe you should try incognito as well, just to see if that helps.
To a specific member of a broader category, such as red, which is a type of color, or rabbit, a type of animal. The specific word, like red and rabbit, is a hyponym, and the broader word, like color and animal, is a hypernym. A word which is a hyponym of one word can be a hypernym of another. Snowshoes are one type of rabbit, and a rabbit is a type of animal. Semantic relationships, like synonyms, antonyms, hyponyms, and hypernyms, are found across many languages, but not all languages draw semantic lines in the same place. For example, English has one word no, while Polish splits this up. It has wiem for I know a fact, and znam for I know a person. In contrast, Portuguese fazer is used where English has both to do and to make. If you look up a word in a bilingual dictionary, you'll often find more than one possible translation, and you need to know further context about how a language carves up the semantic space in order to know which translation to use. Definitions are also useful for describing how words shift their meanings over time. For example, words can become broader in their meaning. Thing used to refer to a council or assembly in English, but now it can be used to refer to anything. Words can also become narrower in their meaning. For example, girl used to mean child, and now it's more specific. And words can change meaning altogether.
Girl used to mean child. You know, when I read different, like, older literature, for example, like Jane Eyre, Pride and Prejudice, and recently Dracula, you can see how language has changed. Even they're using the same meaning, but the same thing, but it means quite different now, you know? So yeah, I guess if they said child and they meant a dude, then that would be interesting. Okay, and I will not comment about Dracula because I have a lot of comments about it. Even though I like it, it is problematic.
Nice used to mean ignorant, and then silly, then fussy, and now, well, nice.
What?
What a journey. One
Nice used to mean ignorant? I guess I'm really nice.
driver of this language change is taboo. We use words as euphemisms to avoid saying ruder words, but then the euphemisms start getting associated with the original meaning, and so another euphemism is needed, and so on. For example, the word toilet originally meant a cloth, and then a cloth used on a dressing table. Then it meant the items associated with the dressing table, like a mirror and a hairbrush, and then a room containing a dressing table with a lavatory attached. Finally, people used this word to refer to the porcelain plumbing item and the room that it's in, because it sounded more polite than, I don't know, crap house? Poop room? Now the word toilet is a bit too direct in some people's mind, and they use another euphemism for toilet, such as bathroom or loo. Or maybe bathroom even feels a little too much for you, and you use a different euphemism like, I'm just gonna go wash my hands.
Washroom.
The euphemism cycle continues. Even as words change, their definitions can still be straightforward. But definitions don't always work so easily. For example, the same sequence of sounds can have multiple meanings, like bank, which can be the side of a river, or a place where people store money. This is known as polysemy, and it only gets trickier from there. Let's see what the thought bubble is serving.
This is an okay. Oh yeah, okay does stand for all correct. That is actually true. And goodbye for God be with you or something. Yeah. Yeah. Godspeed, stuff like that. Is the word acronym correct in that case? Yeah.
Serving up. Let's picture the sandwich we would choose if we were going to draw an unremarkable sandwichy sandwich. We might consider the type of bread. White, whole wheat, square loaf, or something more rustic. And we'll probably imagine a filling. Maybe you went with a PB&J or something with meat, cheese, and lettuce like the emoji sandwich. I went for a grilled cheese myself. Now let's take the sandwiches we pictured and try to write a definition for sandwich. Maybe it's a filling between two pieces of bread. Or wait, a sandwich can be served on a roll. And wraps and pitas are on a lot of sandwich menus, so maybe a sandwich is a filling between two somewhat bread-like pieces.
I guess pita is naan.
A burger works, it's got a filling between two halves of a roll. But what about an ice cream sandwich? It's got a filling between two cookies, and it even has sandwich in the name. And if we're going to count wraps and rolls, does that make a burrito a sandwich? A hot dog? A pizza? What if we fold the pizza? And this doesn't even get into how sandwiches are different cross-culturally. Maybe your sandwich involves Vegemite or liver paste, like the Norwegian matpika. Okay, so our sandwich definition isn't really working that well, and we probably need to figure out definitions for filling and somewhat bread-like pieces. Oh no. We are, to use a sandwich figure of speech, in a bit of a pickle. Thanks, Thought Bubble. Now I want a sandwich. Or maybe 17 sandwiches of different definitions? Anyway, any definition, if we think about it hard enough, starts to break down with exceptions and edge cases. How do we know whether something is a cup? Whether a dress is blue and black or white and gold? And that's not even getting into social constructs like genders and emotions. Maybe nothing means anything ever, and yet somehow we do manage to go through the world and communicate with each other reasonably well most of the time. If I ask you to think of a sandwich or a chair or a bird, you do think of something. So maybe the problem isn't with words. It's with trying to use definitions to express their meaning. Psychology professor Eleanor Roche came up with a different idea. Rather than imagining we have dictionary-style, clear-cut definitions of things in our brain, Roche argued that we instead have prototypes or exemplars, the most typical representatives of a category. Then we have other categories.
I don't know about the goodbye thing you mentioned, but OK is an acronym of the misspelling of all correct. With a K, yeah. Was it I almost said email. What do you call it? Letter. Someone wrote OK as in for all correct. Because I think I've read about or heard about this somewhere in a YouTube video, probably.
Members that are more or less central depending on how similar they are to the exemplar. For example, an exemplar of a chair probably has 4 legs, a rigid back, and seats 1 human. But that doesn't mean that a chair can't have 3 legs, or be extra tall, or be an adjustable desk chair. And most people's exemplars of a bird are small, feathery ones, like sparrows or robins. But that doesn't mean that less central category members, like emus or penguins, aren't still birds. Roche's prototype theory offers us an escape hatch from definitions. We don't need to pin down an exact set of criteria for sandwichhood or chairness. Instead, we can recognize that some examples are really obvious prototypical members of their category, and other examples are more loosely related.
Edge cases.
Both kinds of meaning are totally okay. Delicious, even. Prototype theory works well with content words, words with meanings that we could point to, describe, or draw a picture of. It even works okay with ideas that are abstract, like happiness and democracy. But not every word has a prototype. Take words like the, of, is, or, if, and every. It doesn't make much sense to ask what a the looks like, or try to think of the most prototypical example of an of. These little words that help a sentence fit together grammatically are called function words. They can only really be described based on their relationship to the words they're used with, their function in the sentence. To pin down exactly what these functions are, we can express the relationships between words in mathematical, symbolic terms using predicate calculus. This concept also comes up in mathematics, computer science, or philosophy, where it can also go by the names first-order logic, quantificational logic, and first-order predicate calculus. Predicate calculus is a branch of formal semantics. That's formal as in using formulas, not as in semantics that you do while wearing a ball gown. At the heart of formal semantics is one assumption. To understand what a sentence means, we have to know when the sentence is true or not. And predicate calculus helps us find the meanings of certain words in those true sentences. To see how predicate calculus works for 2 function words, all and a, let's start with the sentence, all Crash Course hosts like Gav. If it's true, we can infer that Gav exists, and that since I'm a Crash Course host, I like Gav. We can't infer how many Crash Course hosts there are, but we know the sentence applies to all of them. So all is known as a universal quantifier. If the sentence was a Crash Course host likes Gav, then we could infer that there's a Gav and that there is one of the set of Crash Course hosts that likes them. It might be me, but we can't be certain. We don't know which Crash Course host it is, only that they exist. So A is known as an existential quantifier. In the sentence, all Crash Course hosts like a rabbit, we now have one universal quantifier and one existential quantifier. This sentence actually has two different meanings. One, there is a rabbit that all Crash Course hosts like, or two, every Crash Course host each likes a different rabbit. It would be hard to write down this kind of meaning in a definition, let alone describe this interaction between all and a in a few words. But using symbols lets us see these relationships more clearly, and lets us see when similar functional meanings are expressed in different languages. We've only explored 2 function words here. There's an extensive set of notation we can use to explore other function words, and some of them are still being figured out. That said, like prototype theory, predicate calculus also doesn't work for everything. These methods are just 2 ways to do semantics. Other approaches to semantics specialize in still more kinds of meanings, such as binary feature analysis, which is useful for precisely describing words that are part of a taxonomy, like words for family members. There's natural semantic metalanguage, where words can be broken down into other, more basic units of meaning, and cognitive semantics, where metaphors draw connections between abstract concepts, like time, and concrete concepts like physical location. Some aspects of semantics highlight similarities between different, unrelated languages. Other aspects highlight meanings that are more specific to a particular language or language family. There's so much more to talk about, and we'd love to get into it, but we don't have time. Trying to articulate the meaning of a word in a dictionary is an amazing skill, but meaning is complicated and nebulous and requires a range of semantic tools to pin down. Next time on Crash Course Linguistics, we'll zoom out further and talk about meaning beyond words in a larger social context. Thanks for watching this episode of Crash Course Linguistics. If you want to help keep all Crash Course free for everybody forever, you can join our community on Patreon.
Cool. Okay. Still not an epoch. Okay, I wanted to double check before I go. Cool. So, thank you for being here. That's it for on my side. I think I just wanted to say that I watched The Wild Robot and I really loved it. I think I made myself quite clear. So if you get a chance, watch it. If not, that's cool. But I really recommend it, especially if it's surprisingly emotional. But I'm sure kids will love it because it's cute. So if you have kids around you, take them. If not, take yourself and go and watch it. It's worth it. Yeah. Okay. Like one of my most beloved robot animated things is Baymax, but now Roz is basically like side by side to Baymax for me. Maybe do I like Roz more? No, I love them equally. Okay. All right. Thank you for joining today's stream. I hope you had a nice time. I hope you learned some stuff with me, and I will make sure to put up schedule for this week just to see if I can try that, because weekends are easier, but let's see what I can do with weekdays. So maybe look out for that if you are interested. If not, that's cool. Can't get over how yeah, it's good. It's the screen copy tool. Yeah. Okay. Thank you. Have a nice rest of your day. Enjoy your weekend and see you next time. Let me see if I can do not a wave. Is this a wave? This is a hello or a goodbye wave. I'm gonna use it as a goodbye. It works. It's cute, isn't it? Because I used to use the other one, but now I'm using this one. See ya next time. Okay, bye.